Greetings! In this tutorial, we will be looking at Service Manager, the centerpiece of the entire framework. Most Zend Framework components use Service Manager to integrate themselves with each other. This is the primary way you bring in other frameworks and libraries into your application, and you will be using it several times an hour to create your own classes. Best way to understand the Service Manager is to think of it as a utility to create objects anywhere in your application. Well, why can't we just say object equals new object of any kind? Well, in the real world it's never that simple. I can identify at least 5 cases where just saying new object is not going to work. If I have any one of these 5 things in 3 or more locations, I know I will definitely need the Service Manager. Why specifically 3 or more? I've worked with some people who find it difficult to understand code that creates additional abstraction layers for small code duplication problems. So if you have a code that is similar in 2 or 3 places, it may be easy enough to maintain a copy and pasted version of just those 2 or 3 places, as opposed to creating a whole new abstraction level that makes it time consuming and more difficult to go through each one to understand where the duplication is. Sometimes it's just really easier to do copy and paste 2 or 3 times. Once you go beyond 3 times, 4 or 5 places, you definitely do want to take away the copy and pasting and put it into a common location. But more importantly, I think you may not see the pattern in just 2 or 3 places. If you try to go for the abstraction of taking away the duplication before that duplication even happens, how are you going to know what to even put in those abstract classes, in those abstract factories? I've worked with people who create these abstraction layers ahead of time before they even understand what the concrete classes should be, and then the abstract versions of their code does not fit the requirements that are actually needed in the concrete versions. And at the same time, I've worked with people who don't bother abstracting at all, creating a new object in any random place, so it is completely impossible to reuse anything. So on to the 5 concepts that Service Manager helps us with. First, simplest one is being able to create an object without any parameters or setters. This may be useful in places such as templates, where bringing in PHP namespace concepts or instantiating whole modules to just be able to do a new object is not possible. We've seen this already when Zend Skeleton Installer created a configuration that matched the controller instance with the route path. In our module configurations, we see a route path that specifies the controller name, and a controller name is mapped to a factory. Then that controller name is treated as a service name, and since it has no constructor parameters or other complicated ways to instantiate it, an invocable factory creates its instance directly. Then we have another typical case where an object needs some kind of parameters to construct itself, or it may need setters. Then we have a problem where we only have a general idea of what we want, but not exactly. In the example of our issue tracking system, when the user clicks the new button, we know some kind of issue needs to be created, but we cannot predict exactly the type the user will pick. So instead, we create an abstract factory that is capable of creating any one of these 4 types, but we don't figure out what it is until we actually get there. Then we have a case where we know exactly the type of the object that we need, but not the parameters that is going to come in. For example, a permission system, where you know that you want a permission object, you know exactly how to create it and a type that needs to be created, but you don't know exactly the permissions that are going to go into it. For that, we're going to use a build method of the Service Manager. And finally, another typical case is having a big object that needs to be created, but we don't know when it needs to be created. So instead of creating it just in case it's needed and then slow down the entire system for most likely nothing, we're going to create a lazy service that will only be instantiated when application seems necessary to do so. Once these objects have been created by the Service Manager factories, still need to decide whether they should be reusable. In some cases, we want to make sure that there's only one instance ever of an object, regardless of how many times it is requested. For example, a user repository needs to be instantiated only once to ensure that regardless of where we request for users, we have a consistent set of users that are being given back to us. Other times, we may want to force every object to be unique. If we make an HTML template system services, we don't want multiple tags accidentally have the same IDs. So every time we call a new instance of a tag element, it will be guaranteed to have a new instance altogether. To get started, we're going to create a simple user object and see if the Service Manager is even needed. As a reminder, all the entities that the application is actually about live in their own module. Here it is the ZFT module. We're going to begin by creating a directory for the tests. Always begin with tests first. And a user test object. Give it proper namespace. This is going to live in namespace ZFT test. The first one is going to be user test object and extending from PHP unit framework test case. Since we have created a new root namespace, we have to add it to the composer, that otherwise it will not see it. So that is a ZFT test, lives in the ZFT directory, and finally have to add it to the list of suits that need to be executed. And give it more appropriate name. These are application entities test suite. And let's also move it to the top. And now we can run them. Here we see the entities tests have been added alongside the web issue portals. The first thing we need to be able to do is to verify that we can create the user object in the first place. Test can create user object. In the application, we will be expecting to create users this way. User equals new user. Once the object has been created, we will expect this to be an instance of user class. So the actual user is user, and its expected type is going to be user class. If we run a test now, it's going to fail because ZFT test is not found. So we can create an actual user object now. Set a namespace to be ZFT. It's already defined in the composer, so we don't have to do anything else. We can go straight to creating the user class. Having the user class defined, we can rerun a test, but it will still fail because we have not explicitly imported it over to where we're using it. Now that we have, we said use ZFT user. The user definitions match. We can rewrite the test, and everything now passes. What good does this do to us? Well, now we can go into our controller or pretty much anywhere else in the application of the portal, and we can just use this as a scratchpad for now. We can say user equals new user, and because we have our unit test, we have full confidence this will work. Put a breakpoint there, go to our website, make sure we have the breakpoints listening, go back to the website, and here we have the user object created that came from our entity module. This looks like a good place to make a commit. We're going to call this adding user entity without service manager. Committed. So far we did not actually need service manager, but what happens if we don't just want to create blank user objects, we want to fetch existing one from some kind of storage, be it a database, a cloud provider, an authentication service, anywhere beyond the control of our PHP code. We also want to verify that if we ever request the same user ID in multiple places, we get the same object back. We don't want to be in a position where if we have two chunks of code that both request user ID number 5, for example, and we edit one, the second instance will be out of sync. The technique for that is called the repository pattern, and we will be using the Service Manager factory feature to create this. So as before, we're creating a test first. The user repository is going to live inside of the user namespace. Starting with the user repository test class that lives inside of ZFT test namespace, user object, user namespace, and class user repository test, which extends PHP unit framework test case. And just like before, we need to verify that we can create this object. So test can create user repository object. The way we create this object, or this repository, is by saying new user repository, and it's going to need some kind of identity map to keep track of the users already loaded, and the data mapper that will take the raw data from some kind of storage, be it a relational database, Postgres, MySQL, a cloud service like a Google account, or frequently what I see, an Office environment with a directory service like Active Directory from Microsoft. Once the repository object has been created, we need to assert that is an instance of user repository class like that. Now, of course, for the creation of the actual user repository object, it is going to live underneath the user directory user namespace. So the pattern here that's commonly used by Zend Framework, so we're going to follow it, is to have an object that represents some kind of big system to be at the root level, and then the supporting classes to be a level underneath it with the same name. Alternatively, you could have written user to be a part of the user namespace, but if we do that, then whenever we create a user object, we're going to have to say new user namespace user class, which looks really awkward. So it's much more natural to just say new user, but then user repository to be underneath user namespace, user repository. So this style of having a class to be outside of the repository of the supporting classes to have a nice, neat instantiation names. In fact, we can take this further and take away the user altogether from the name of the class. This way we have a nice, consistent name representation. So we have a repository for user, repository for issue, repository for group, repository for anything, and it's going to be called nice and simple repository, and you can differentiate them by the namespace that they belong to. So this looks even neater. So take away the demo code. I'm going to create the actual repository object, add it to Git, put it into namespace ZFT user class repository. PHP Storm is being a bit buggy here. Need to refresh the namespace, and here it is, being able to see it now. And back to tests. Repository is now coming in from user. And just in case we have more than one repository, it can be useful to do this. It's just a little personal style. You can pick your own way of doing things. I just like seeing that. And just for the record, if you have a problem with slashes, what you can also do is say use ZFT user repository as user repository. This is also a very common and valid technique. So you can take a pick how you want to do this, one of three ways. Without going into too much detail of the next subject of how repository connects the application code to the database, I'll just quickly note that to instantiate a repository, we need an identity map, which is responsible for keeping objects that have already been queried in memory, be it PHP memory or some kind of memory database like memcached, and a data mapper that does the actual permanent storage. Each of those are going to in turn need quick interfaces. Namespace ZFT user interface identity map interface, and not going to worry about the definitions right now. Same one for data mapper interface. Where does this come from? Yes, I do need to configure my templates better. Put that over here, and this is data mapper interface. Now, why interfaces are better than actual classes in the passing around of arguments in a service manager especially, is if you have more than one version of these, you might have data mapper for a relational database, or you might have one for a cloud provider, that's getting popular these days, you need to make sure that they all have predictable, reliable, consistent function names that work the same way regardless of what version you have. That's why when we create a repository object that needs those, we're not just going to say, well, I'm expecting a data mapper from MySQL. I am going to say, I need a data mapper or identity map interface in general. This is especially useful in testing. So back to our test. When we want to make sure that we can instate the user repository object, we don't want to deal with the complexity of creating identity maps and data mappers. We're not in business at this point of establishing a connection to a database, so why are we going to make a database data mapper or cloud provider data mapper? Instead, we're going to create stub classes that only have the definitions of the interfaces but not the actual implementation. So this will depend whether you are on PHP 5 or PHP 7. In PHP 5, it's a bit more awkward. You actually have to create an additional class here, which will identity map stub, and it has to implement identity map interface, for example, and then you have to make a new instance of it. So identity map stub equals new identity map stub, and then you pass this into here, pass that as the first parameter, and the same deal for the other one. You say data mapper stub implements data mapper interface and data mapper stub new data mapper stub, and I will take that and put it here. So now when we run the test, things pass. Now this is awkward. We don't really want to have all of these classes inside here, and they kind of get in our way when we do our code completion. If you're in PHP 7, so let's leave this for PHP 5, and it gets much worse if the different tests that you're going to run are going to need different ways to instantiate them. So right now we only have one, you may not have the problem, but if you have more of these tests and they will need different test values for each one, it's going to be pretty difficult to have to override each of these stubs for each individual test that gets run within the suite. So instead, we can have the class created just in time before the test runs using an anonymous class function. So we can say new identity map. Anyway, let's leave this on PHP 5 version. And the PHP 7 that I'm going to be using is identity map stub equals new class that will implement user identity map interface, and then the data mapper stub equals new class implements user data mapper interface, and everything should be working again. Should have shown you how the tests work. There we go. All tests pass. What does all of this have to do with Service Manager? For the past 10 minutes, it seems like I've forgotten my original purpose. Well, to take proper use of Service Manager, especially its factories, you need to have all of this information. You need to have interfaces so that you know what's coming out of it when you call a particular service name. And you need to know exactly how to create it so that you can make a factory that the Service Manager can use to create a service that you have asked for. To emphasize that, I'm going to split the screen here so we can see what it is that we need and build a Service Manager factory based on this. To enter this information into Service Manager definition, I'm going back to the module file of the ZFT namespace into getServiceConfig function. This is that function from the first tutorial of module introduction, where we return an array of definitions of what Service Manager will do. To figure out how to get this done, I will reference the official documentation. Here we see we need a factories key that is an array of service names. Each one needs to be either the name of a factory that creates that class or a callable function that creates that class instance. How to actually define those classes or callable functions? We go down and we see that the function that we give to that key takes in two parameters, the first one being the container, the service manager itself, and the name of the service that we're trying to create. So let's play with that. I'm going back to module in ZFT namespace, getServiceConfig function. This is the function from the first tutorial that we know gets called when Service Manager instantiates and picks up the configurations. So we're going to configure it by saying that there are factories, which is in turn another array, and now we need to give a list of factories that we have available. Two ways to do this. One, we can either give it a string name, so we can say ZFT.userFactory. I'm just putting the initials in front of the name in case you have multiple modules and you can get easily lost where each factory comes in. Or another more reliable way, which uses strict typing of the IDE to help you out instead of typing in manually strings. You can say repository from ZFT user and class. This will give back the string name of the object that we want to get. And this looks somewhat confusing, so we're just going to say as user repository, because just repository is slightly meaningless. And we said for starters, we're going to do a callable function. And from our perspective, we just need to return user repository. But from our test runner, we know that we also need the identity map and a data map. So where are those going to come from? Well, we know that the Service Manager gives us a reference to itself as the first parameter, and it calls itself a container. And it's mildly confusing. And the second parameter is the name of the service, just in case we need it, that we're trying to instantiate. Now, why does a Service Manager calls itself a container interface in this case? That's because a lot of the frameworks actually do this. The Service Manager concept is common throughout the entire industry, be it PHP, Java, anything you pick. This whole concept of passing around dependencies of one class into the other. And how do we have the same interfaces across every framework that we use? We want to make sure that whatever code we write in Zend Framework isn't going to suddenly break in Symfony and the other way around. We don't really want to isolate every other framework and not able to use any Symfony or anybody else's modules just because we picked Zend. So what do? We create a consistent set of interfaces, much like we've done in our unit tests, although this time it's the framework authors that made those consistent interfaces, that they're all going to have these predictable function names. And in our case, the predictable function name is Service Manager get and has. So the framework community across the entire PHP world has agreed to have all dependency resolutions, whatever they're going to call them, to have these two methods. And they all agreed to call this dependency resolution mechanism a container. So in essence, they said, let's put all the dependencies that a particular class needs into a dependency container, and that's where the name container came from. So for this case, we are going to need a user identity map, which we actually don't have ready yet, but let's just create stubs for them real quick. And data mapper equals service manager get, and we'll get the data mappers out of there in a second. Once we create them, data mapper like that. For now, let's just say that these are going to be very simple objects that don't have any requirements. We'll just have memory identity map PHP git namespace user from ZFT plus memory identity map that implements identity map interface, and same thing very quick for, let's say, Postgres data mapper implements data map interface. Okay, so they don't have a constructor, or they have a constructor that is very simple, doesn't have any parameters. To instantiate those kinds of services, if we forget, look back at the configuration that the original skeleton installer gave us. Here we see that there's a special factory called invocable factory. This is a factory supplied by Zend Framework, which creates instances of objects that don't need any parameters in their constructors. So borrowing this concept, we're going to add them here. We're going to say Postgres data mapper is done by invocable factory, and the identity map, or rather memory identity map, is also done through invocable factory class. Having those defined, we can now in the get put in whatever the keys are for our factory definitions. So Postgres data mapper, actually memory identity map, and Postgres data mapper class. There we go. And that concludes the requirements for the user repository. So despite this working, I don't recommend using it this way. Instead, I want to go towards the part where in the documentation it says I should be creating my own whole class for the factory, not just an invocable method. I have two major reasons for that. One is testability. It's easier to actually test what a factory does. It's sort of impossible to do this reliably in a test. But a bigger reason for me is that the factories are very often not used in Service Manager alone. I want them to be a utility, always ready for me to be there, regardless if I need them through a Service Manager or manually in any other place. And if nothing else, it just cleans up the module class because it gets busy very quickly with all the other methods that instantiate the module. So what does the documentation say we need to do? Well, we need a object factory of some kind. So in our case, it is a repository factory PHP, the namespace. I should add this to my template generation. The class repository factory, and the documentation says it needs to have a factory interface. Take care that you pick the factory interface, not the deprecated one from Service Manager. That is the compatibility between version 2 of Zend Framework and version 3. Pick the version 3. Implement the missing methods. That's the invoke. And we move all of this into here. And they call it container, I call it Service Manager. User repository is getting imported, not the test, but and I will say repository factory from here, from class. So this will achieve the same effect. In the excitement, we may have forgotten to create the tests first. So let's do that and pretend we did them first. Repository factory test. And this is actually going to be somewhat more difficult because this factory depends on a service manager to do its job. So how are we going to mock a service manager, which is a whole big difficult component, into our small test runner? So this one is in the ZFT test namespace for user and class repository factory test framework test case. We want to verify that we can create user repository. We have the Service Manager instance already. I'm going to populate it slightly later. Now we need to go into the factory equals new repository factory. We're not going to specify exactly that it's a user repository factory because we're already in the user namespace, so it's pretty evident. And then for the actual repository, we're going to say factory and bracket. We're going to use it as a function because according to the interface, we have an invoke method, which means that this class is actually being used as if it's a method. And the first parameter we know needs to be the service manager. The second needs to be the name of the service that we want to create, which in this case we're verifying that we're creating a user repository. So user, or rather just repository factory. And the options for it are optional, so I'm not going to put anything there. For verification, we will do an assertion that the instance is actually a repository. And we could also theoretically go into verifying that the repository has indeed accepted the instance of these, but we don't have an interface for getting them. We will test it implicitly, but that's something that you could do. You could also have a getter method that verifies that these have been applied to some private property. But here the test should fail because we have not populated the service manager. and it has indeed enabled to resolve factory. To fix that, I'm going to borrow my stubs from the other tests that we have and push them in the service manager. So sm set factory. So one is going to be an identity map, which is actually a memory identity map, which takes in a callable, which is going to be a function that returns new class, which implements, fix up the namespaces, and one more time for data mapper. It's going to return new class which implements the data mapper interface. And now the test should be slightly more happy. There we go, we got all of them pass. The final thing to note before we end is if we go back to repository factory, and at the point when we implemented the invoke method from the factory interface, we were also brought in by the IDE these three exceptions in the use statement. We got a container exception, service not created exception, and service not found exceptions. These are exceptions that you are expected to throw whenever you know there is going to be a problem. Remember that when we messed something up here and our tests failed, we had this exception, unable to resolve service to a factory and so on. Let's look exactly how that got here. So we'll look at the definition of Zend Framework's own code. We got a service not found exception being thrown when we are asking for it something that does not exist. So in the getFactory method, there is a bunch of difficult things that we're very thankful Zend Framework team for creating, followed by the throw new service not found exception with a message when something in the middle here breaks. That is one of the exceptions that we are given by default. We can look at its own definition. So that's an example of what the users of your code or even yourself will expect to do. If you try to create something and it's going to crash the PHP and give you a fatal error without any good meaning, when you know that's going to happen, or you couldn't predict it happened, but you did find out that that's a problem, put in a condition for that statement that you know is going to break something, and make sure you throw the exception. At this point, you should have enough information to create a controller factory so that you can use this repository inside of our index control as an example. In the next tutorial, we will go through doing that very quickly without all the background theory. We're just going to hammer at pushing repository into the index controller. And then we still have a couple of other factories to do next time.